In this tutorial, we'll look at a bit of number theory and we'll focus on modulo congruence. I have 3 examples prepared, and the very first one asks, prove that 7 is congruent to 9 modulo 2. Now before we start answering this question, the way that this would be written in literature would be 7 with the equivalent symbol 9 mod 2. And we want to prove that 7 is congruent to 9 mod 2. Just before we start, 9 mod 2 is like asking the remainder of 9 divided by 2. The top number is the numerator, the bottom number is the denominator. Also, the top number is called the dividend, and the bottom number is the divisor. And when we divide two numbers like this, we take the divisor, and showing it as long division, the dividend would be over here, and the output is called your quotient. So, what is the remainder of 9 divided by 2? Well, if we use this logic, then we have 2 in that position, 9 here. 2 fits into 9 4 times. 4 times 2 is 8, and we end up with a remainder of 1. So we want to show that 7 is congruent to a remainder of 1. With that being said, let's look at a definition. Let m be a positive integer, and let a, b be elements of the set of integers denoted as this double struct z. The phrase a is congruent to b modulo m means that m, so in our case 2, divides, that line suggests divides, the difference of 7 take away that number. So again, 7 is our a value and 9 is our b value. So does 2 divide 7 take away 9? Absolutely. Negative 2 happens to be a multiple of 2. And when that's the case, we can conclude that 2 divides negative 2, and therefore 7 is congruent to 9 modulo 2. If that was confusing to you, let's take a look at another example. Find the value of x such that x is congruent to 3 mod 6. Let's begin with an understanding of what this 3 mod 6 means. As a reminder, this number right here is the dividend. And that number is the divisor. So if we divide this out by long division, we have 6 in that position, and the dividend goes in here. 6 does not fit into 3 at all. So we put in 0. 0 times 6 is 0. And we subtract these two numbers, and we end up with an output of 3, which is our remainder. So what x value is congruent to 3? Using that definition from before, we'll write 6 divides, our a value here is x, and our b value is 3. So which x value will satisfy the fact that 6 divides the difference? It should look something like this. X take away 3 divides 6. If we end up with an output, or a quotient to this statement that is an integer, then whatever that value of x is satisfies this expression. Now for 6 to divide some number, in our case x take away 3, x take away 3 must be a multiple of 6. All multiples of 6 can be expressed as 6k, where k represents any integer. That being said, x take away 3 needs to equal 6k, as shown. And from here, we can solve for x. I'll bring that negative 3 over. I get 6k plus 3 is equal to x. Just to give you an idea of how this works, let's set k equal to 0. If I substitute k into this equation that I just made, I end up with x is equal to 6 times 0 plus 3. X is equal to 3. Substituting that 3 back into this expression gives us 3 take away 3. Let me show you that. That's equal to 0. Because 0 is a multiple of 6, 6 divides 0, so the expression we found works. And that's the answer to the problem. Finally, in our last question, we're being asked, what are all possible remainders of mod 5? This is an interesting question, because to come up with the answer, all we have to do is a bit of experimentation. Let's look at 0 mod 5, 1 mod 5, and go from there. Let's see what this reveals. 0 mod 5 is like saying 0 divided by 5, which is the same thing as saying 5 in long division terms as our divisor and 0 as our dividend. 5 fits into 0 0 times. 0 times 5 is 0, and the remainder is 0. So that is a possible remainder. Let's try 1. 5 does not fit into 1 at all. Again, 0 as a quotient. 0 times 5 is 0. And if we subtract, we get a remainder of 1. So that also works. Let's try now 2 mod 5. Again, 5 as the divisor and 2 as the dividend. 5 fits into 2 0 times. 0 times 5 is 0, and we get a remainder of 2. Let's try 3 mod 5. 5 does not fit into 3. We multiply and we subtract, and we get a remainder of 3. So a remainder of 0, 1, 2, 3 work. Let's try 4 mod 5. Again, 5 does not fit into 4. 0 times 5 is 0, and we get a remainder of 4. Now what's interesting is, once we reach 5 mod 5, we get a different situation. You see? 5 divided by 5. 5 fits into 5 once. 1 times 5 makes 5. Subtracting these, we get a remainder of 0 again. So we get a repetition. You cannot have any remainders outside the range between 0 and 4. To generalize this, if we set this number as n, then all possible remainders of mod 5 are between 0 and n take away 1. In our case, 0 to 4. If that were mod 10, then n would be 10, and the remainders would be from 0 to 9, and you get the idea. If you have any further questions, please leave them in the comment section below. Otherwise, thank you for watching, and we'll see you all later.